Hello, my name is Asim Bilal, and today I will be presenting a presentation on a research paper, Collaborative Filtering with Entity Similarity Regularization in Heterogeneous Information Networks.
So basically, I was going to start with the introduction. And for the introduction, a recommendation system is a subclass of information filtering system that seeks to predict the rating or preference a user would give to an item. Recommendation system can be found everywhere right now, like in the Amazon, eBay, Netflix, YouTube, Facebook. Now, how heterogeneous information networks works? A heterogeneous information network contains user, movies, actors, and genres as entities, and the corresponding ratings and entity relationships. The major challenge of utilizing all different types of information in a heterogeneous information network is to combine user rating data with various external information or relationships. Second, learn the importance of each factor. In this example, besides user movies and the user movies rating relationship, other type of entity is also exist in a bigger picture. How information network is useful. Various types of information and relationship complement each other. Number of ratings and a cold start. Ground and preliminaries. Heterogeneous information networks, metapath based item similarities, low rank matrix factorization, and problem definition. An information network is defined as directed graph. Each entity belongs to an entity type and link belongs to a relation type. We call an information network a heterogeneous information network when an information network begin recommended as items. What is metapath based entity similarity? In a heterogeneous information network schema, two entity type can connect via different paths. In order to distinguish these paths in network schema from path instance in a concrete network. Low rank matrix factorization. The key idea of matrix factorization is that there exist and latent structures in the data by uncovering which we could obtain a compressed representation of the data by factorizing an original matrix to low rank matrix. Matrix factorization provides a unified method for dimension reduction, clustering, and matrix completion. Matrix factorization with metapath based entity similarity. The underlying assumptions is that two items EI and EJ with high composed similarity score SIJ more likely to share similar low rank representation VI and VJ respectively, thus half similar rating by whether they are observed or unseen. The first part aims to learn the low rank representation U for users and V for items, and second part is to learn the path strength. Empirical studies. The dataset we used The dataset we used in empirical study is built by combining the popular movie length 100K dataset and the corresponding IMDb dataset. As you see over here, there are two graphs, feedbacks, one that you can see into figure B, That's rating versus users, and the other one is rating versus item popularity. We implement several widely deployed or state-of-the-art recommendation models as follows. User mean use mean value of the targeted user to predict the rating. Item mean use mean value of the targeted item to predict the rating. Non-negative matrix factorization function in MATLAB on R with b equals to 40. Weighted non-negative matrix factorization on R with different dimensionality settings like d equals to 10, 20, and 40. Now, as you see over here in the equation, we use mean obsolete error MAE and the root mean square error RMSE to evaluate the performance of different methods. MAE is defined as you see in the formula, and the RMSE defined as we random sample training dataset of different sizes 40%, 60%, and 80%, and use the rest of the dataset for testing. User mean use mean value of the targeted user, and the item mean uses the mean value for the targeted item for the prediction of rating. Weight non-negative matrix factorization on R with different dimension settings like b equals to 10, 20, and 40. The performance of non-negative matrix factorization function is worse than user mean and item mean. Implementation of weight non-negative factorization was also done, and the performance of this method can easily beat other baseline methods in all training and testing partitions. Over here we have different performance analysis. First represents performance change with user training. Other graph represents the performance change with item popularity, and the conversion rate shows in the third graph. However, when item have sufficient rating, weight non-negative matrix factorization function and HETA matrix factorization can provide high quality recommendation result as expected. When recommending items with insufficient rating, the proposed method HETA matrix factorization perform better than weight non-negative matrix factorization, although both methods suffer from cold start problem. Based on this study, they have observed that adding information network data as external knowledge can be an alternative this issue. Now comes the conclusion and the future work. Study recommendation system in the light of heterogeneous information network. Compare the proposed approach with the state-of-the-art recommendation techniques. Analyze the performance of these methods under different scenarios. Interesting future works include adding user or item rating triage to the proposed method to elevate cold start problem. Online version of the method to incorporate newly generated ratings. That's it from my side. Thank you for your time.